Welcome to the lesson number 18 of C++ programming language. In this video, we will study about loops and which loop? For loop. So the plan, first we'll see the basic syntax and followed by most common use case. Then we'll discuss few things about loop head, that is variable, test expression, other statements. The loop body, scope of loop variables, break, continue, nesting, and few working programs, 2 or 3. First of all, the basic syntax. Here is the syntax. For, then some initialization statement, then test expression, followed by semicolon, and then other statements. So what is essential? For, this is the keyword. Initialization, normally we use some variable which is initialized to some number or some initial value, followed by semicolon, then test expression. So if this test expression fails, that is if it is false, then the loop does not enter, it is not entered, otherwise it enters and executes these statements. Okay, followed by some statements. Now here, this is called loop head. This is loop head. This one. This is loop head. And all these statements within this pair of braces is referred to as loop body. Now, if you want to execute only one statement as a loop body, then it is not essential to enclose it within pair of braces, as I have told you a number of times. Now, for is a keyword. It means you cannot use it for any other purpose except for which it has been defined. Now here for, this opening parenthesis, this semicolon, and closing parenthesis, these are essential. Everything else is optional. Now let us see the most common use case. So here I have declared one variable I equal to 0 of type integer, semicolon. This is the test expression, and I++ increment statement. You can write decrement statement as well, as the case may be. It is up to you depending on the use. Then what happens? This initialization is done only once. After this, the program enters this. It tests the expression. If this value is true, if this test expression evaluates to true, the program enters the body of the loop. It means it will execute this one. Okay. Otherwise, it will go out of it and start executing statements following the for loop. Okay. After executing these statements, again it goes back to, or it goes to the third element of the head of the for loop. Okay. And then after that, it comes here. So let me redraw. It starts here, comes to this place. If it is true, it comes here. If it is false, it goes here. Then if it is true, it executes and then goes here. Then it goes here. So this is the way it keeps on executing. So how many times this loop would be executed? I equal to 0 through I equal to 4. As soon as it becomes I becomes 5, this test expression fails, or that it is false. So this loop would be executed 5 times. So what is the loop head? As I told you, here this part is the loop head, and anything which you write within the pair of braces is called the loop body. So here it is, the loop body. Loop variable. What is the loop variable? Here I is the loop variable because I controls the number of times the loop body would be executed. Test expression, as I have told you, I less than 5 here is test expression. Then increment decrement statement. This is the increment decrement statement. Now remember, no relation among head elements. So it is not essential to have I here, and I here. These three statements can be independent of each other. But in most common use, we use them. They are related to each other, but it is not essential. You can have variable I here. You can test for some other condition, and then some other statements. Okay, so but this is the most common use case. The scope of loop variables, the same example I have written here. But now after this, if you try to print the value of I, there will be a syntax error because I is local to the loop body and loop itself. So I has been declared inside the head, I equal to 0. So value of I, if you have defined or declared another variable I before for, that is different issue. But assuming it has not been done so, so if for the first time if I is appearing here, it is treated as local variable to for, and outside that loop body it is not, it does not exist at all. So that is why it is syntax error. So a scope of loop variables is the loop body. A pair of braces makes a scope. So wherever, whether inside the body of if or switch case or a normal main function, anywhere if you make a pair of braces like this, it makes a scope. And any variables declared inside the loop body are local to the body. So if you declare any variables here of any type, they will be treated as local variables to this pair of braces. So outside that pair of braces, it is undefined. Now break. Okay. So the same example I am using. Okay. But the only thing is break. So what happens is initialization done, then test expression, it is found true, it starts executing these statements, and if break is encountered, if break is executed, the loop is broken from this point itself and it comes out of the loop, out of the body. The loop terminates and the program comes out of the loop body and resumes execution of the statements following the loop body. Break is a keyword, so you cannot use it for any other purpose except it has been designed for. Breaks the loop at this point itself, as I have told you. Loop breaks if break is executed or the text expression fails. I should not say it breaks the loop when test expression fails. When test expression fails, then it does not enter the loop, and it breaks the loop if break is executed. Now break breaks the loop, that loop only inside which it has been executed. Okay, so you may have a for inside a for, and if the break is executed inside the outer for, then outer for loop would be broken, not the inner one. So only that loop is broken inside which the break is executed. Then continue. Now break breaks the loop at that point. Here, if it happens like this and it keeps on executing the statements of the body of the loop, as soon as continue is encountered, as soon as continue is executed, what happens is it skips the remaining statements of the body and continues with the third element of the head. So you entered here, initialized here, tested, entered, and if continue is executed, you skip the remaining statements which are written after continue, and it enters the third element, the head of the for loop, and continues with the third element, that is the increment statement in this case. Continue is also a keyword, so you cannot make use of it for any other purpose except it has been designed for. It skips the remaining body of the loop and continues with the third element of the head, as I have already told you. And just like break, continue affects only that loop inside which it has been executed. Now nesting. So you can have a for loop inside a for loop inside a for loop, and so on. So there is no limit on depth of nesting. You can have as many for loops inside one another as you require. So now let us see a few programs which I have written. On the left hand side, I will execute it. Okay, so name of the program is for This is the smallest for loop. As I told you, only essential ingredients are present here. FOR, for keyword, opening parenthesis, nothing here, semicolon, nothing here, semicolon, nothing here, and closing parenthesis and semicolon. Because it is a statement, it has to terminate in a semicolon if I am not making use of pair of braces. So here it is an infinite loop. There is no condition to break this loop. So how to terminate it? It is doing nothing except it is looping forever. So how to stop this program or abort this program? It will depend on the operating system or the platform which you are using. In case of Linux or like operating systems, if I press Ctrl C, it will terminate the program. So this is the smallest legal for loop which you can have in your C++ program. Now let me load another program which is infinite. So I will type infinite. Now here what is being done? This is also an infinite loop. Here it is its body. Now what I'm expecting is type in an integer. It can be signed integer. Cin in older compilers, by default value of val could have been arbitrary value, random value. But nowadays I'm using C++ 11. So by default it initializes it to 0, but do not depend on it. So you make sure what is the value of val always. So you supply a value integer. If value of val is 0, it will break. It will come out of the for loop here. Otherwise, it will print the value here. Okay, so now let me check. So here it is asking me to do this 4. I have typed 4. So it is an infinite loop. It will continue. If I say 0, comes out. Now let me execute it once again. If I say 4.5, what is happening? It has read value 4, but decimal point, it does not read. It is not an integer. It is unlike you can say unlike scanf of C programming language. I could have used scanf here, but just to avoid the use of C++ specific functions and properties, or you can say other constructs, I would like to stick to the C++ specific constructs and keywords. So cin I used, it broke. Now let me, so it read 4 and decimal point is not an integer. Okay, so it skipped it, printed this and came out of it, because as I told you, val was initialized by default of 0. It says okay, break, because it did not read decimal point. Okay, successfully it did not assign any integer value to val. As I told you, by default it was considered to be 0, or it executed break, came out of it. It did not print any value. Okay, now if I type some character, it comes out of it, because it did not initialize it. Value of val is not 0. Okay, so if val is equal to 0, it could not initialize, so it has come value of val is 0. It came out of it. It did not enter into infinite loop. This in older C++ compilers, I have checked this. It used to enter into infinite loop just like C programming language. Okay, so let me load another program for continue. Okay, let me clear it first, then dot for continue. Here also again have beautiful infinite for loop. Okay, here now I'm saying cin.fail. It is a member function. We'll discuss this in more details when we study object-oriented programming concepts. So cin.fail, if it cannot assign or if it cannot read the expected data type properly and assign the value to val, the fail bit is set. So we can check it, cin.fail. If it has failed, then we'll say cin.clear. As I told you number of times, every device is associated with a device file, and a device file and the device is associated with a buffer. So whatever you type at the keyboard, actually it goes in the form of a stream of characters or ASCII codes into that buffer. So buffer is not cleared, so we check, okay, we did not provide an integer, we did not provide it an integer, so reading was failed, reading failed, so cin.fail. This will be true. If it is true, then we say cin.clear, it will clear the flag, and then I will say getchar. I use in C programming also. Getchar, it will keep on reading characters until it reads all the characters, and it says continue. So it means clearing the buffer like this, and it continues. It means where does it go? It goes to the third element. It means it will automatically enter this loop once again. And if val is 0, then break. So this is the way I can make my infinite loop behave like this. So if I say 4, no problem, -5, no problem. Now let us type some real number, 4.5. It says 4. So first it has read 4, it found it as an integer, then followed by a decimal point. It is not an integer. What does it do? It executes this cin.fail, clears that flag, and then getchar. So it removes from input stream the decimal point, okay, and then it continues. When it continues, it means it will come here, but now it will not wait, type in an integer, because it has cleared the decimal point, but not the 5 digit. But so it assumes that we have already provided 5. So from the buffer it reads in integer 5, so it prints, type in an integer, which is, it assumes that we have typed 5 because it is there in the buffer. It prints 5 and then again continues. It means it will come back here and then again it will be waiting. So it is waiting for me to type in some integer. Okay, it will continue. Now if I type some ASD, some characters, it will keep on reading those, and by making use of getchar, it is removing those characters from the input buffer. So 3 times, 1, 2 and 3. Okay, so first time it removed from here, and then it is now waiting for me to type in some number. So let me terminate it, 0. Fine. Now let me load the final example program for itself, and on the left hand side I will just clear it and then for. I can see here. So here I have used for set precision. Okay, IOmanip. In one of the previous videos I have already told about these things. So here what I have done is I have declared a variable, initialize a variable int I to 0, I less than 5 test expression. But here I am not using increment or decrement statement. Here I can use cout. Surprise? Because I told in the beginning that these elements are not dependent. They have no relation. They are not supposed to have any relation among them. So cout OK, it will print OK. Here comma acts as an AND operator. Then it will print the value of I. Okay, this is the way it will print. And then I++, so I am incrementing inside the body, and there is only one statement. If I say cout I here, so there will be a syntax error because this I has been declared inside the loop. So I is not defined here. So now you can see here how many times this loop would be executed, 5 times. So it has to print OK space and value of I from 0 through 4. Now you can see here OK 1, because initialize I less than 5, it will not print here. After I less than 5, it will come here. So I++1. So when it prints for the first time, and this value of I has already become 1. So that is why it starts printing from OK space 1, OK space 2, OK space 3, 4, 5, etc. Now come to the next one. Now I have declared this I before this for loop. So that's why I have not written int here. So now this I variable would be accessible within the for loop head as well as body. Okay. What am I doing here? I am writing now some statement in the initialization phase itself. Now you can see here, before the first semicolon, I have written this one. It is legal, it is true, it is correct. I equal to 0, then cout enter. It will print this value of I at this point is 0, and then it will print this this comma also, and then initialization terminates here, that phase. So it will print, remember this part would be executed only once. So it has printed enter 0 followed by OK1. How? Because after this it has tested the expression, found true, it enters the loop and it enters the body of the loop I++, and from here it is going to this cout OK and value of I as 1. So this will be printed like this. Then the loop executes OK2, OK3, OK4, OK5. Okay. Now the third for loop. Here, don't get surprised. We never said that in initialization steps you have to have integer always. You can have any type of variable and you can initialize. So suppose I'm using float, f equal to 0.3, f less than equal to 1.2. So how many times this loop has to be executed? 0.3, 0.6, 0.9 and 1.2, 4 times. Okay. Then the increment decrement, it is not essential that I have to use plus plus or minus minus. In any case, with floating point variables, plus plus minus minus are not applicable. Okay. So it is less than 1.2, it will print the value of f, then it will increment the value of f by 0.3 and so on. So we expect it to execute, this loop to execute 4 times, but you will see here it has printed 0.3, 0.6, 0.9, only 3 times. Why this? You can figure out if you have watched my previous videos carefully. So this cout I have purposely written here so that there is a gap here. Now I just want to change the precision. Instead of having some 6 digits after decimal point, and if they are not significant, it prints only 1. So it appears to be correct. But now if you see in details, set precision 8 digits. Now the same statements, now you can see here, it has printed 0.3, 6 zeros 1, 0.6, 6 zeros 2. It means 0.3 is not being exactly represented. Actually, it is represented as a number which is slightly greater than 0.3. So after 3 iterations, the value of f has become 0.9 and slightly greater than 0.9. Now you add some number which is slightly greater than 0.3 to some number which is slightly greater than 0.9. So the result would be greater than 1.2. So this test condition fails. And that is why you may be surprised that you expected this to execute 4 times, but it executes 3 times only. So I still maintain, do not rely on floating point computations, as every real number cannot be represented 100% exactly in IEEE 754 standard. So these were the working programs. There are 2 types of loops in C++. One is for loop, which we have just seen today. And in the next video, we will study while loop. While has 2 forms, while and do while. Okay. So we will study that in the next video. That is all in this video. Thanks for watching.